Always.
So, ladies and gentlemen, panie i panowie, Danilo Poccia from Amazon Web Services.
Thank you. Thank you, everybody. So I'm really glad of being here, and we talked with Mirek what could be a couple of possible topics that could be of interest. So this is the first one that came to our mind. It was to show how a couple of products that we quite recently announced. AWS Lambda was announced last year at reInvent, so in November, and the API Gateway that was announced in July in the New York Summit. These two services really can help people develop applications in an easier and quicker way, because the main purpose of the cloud is to help people build new things without having to manage the effort of managing the infrastructure, the complexity of managing a transactional database or a complex analytics platform. So in this case, we focus on these two services, and let's start with a story that I think it's quite common for a lot of people. You have an idea and you want to build an application, so something that can happen in a startup, or it can happen also in a large company where there are this huge core of new innovation when they try to build something new for a large enterprise. So you have this idea, you want to build a new application, and you usually start building this application somewhere close to you, like your laptop that's probably living with you most of the time. And you have your application and maybe some fake data that you use to build up this application. Everything is installed in your laptop. You start building the application, everything goes great, and then you want to go in production. So you probably move your application and some more robust infrastructure than your laptop, maybe a cloud provider, maybe some physical server. But what happens is that customer users will start to arrive, and they will start to arrive with different platforms. Probably 10 years ago, people would build an application for websites, so you would just expect users to use your application via web. But now every application is expecting to have consumers that use mobile applications, so smartphones, tablets, and probably in next year, we will see the wearable and the Internet of Things devices growing and growing as consumers of our new application, the new application that we are building. And probably data is behaving very differently from your application, so you will want to move your data into a different platform than where your business logic is. And what happens is that probably your data is files. By files, I mean everything that is unstructured content, and some more structured content that probably you would put into a database, maybe a relational database, maybe a NoSQL database. That depends on what do you like. And your application will receive this connection from these different devices, and we start to see different behaviors, because the new devices, the smartphones and the wearables, will probably just do API calls to my backend application. They will not do anything different. But we still have these old-style websites where we also must provide the whole content and the whole layout. And this is something that is breaking the behavior of my application. Sometimes we see companies and startups that have to build two different backends, one for mobile and one for the traditional websites. So what we suggest is that what also we see that a lot of people is doing is to transform the website into clients using JavaScript, because the browser is just another virtual machine where you can install an application via JavaScript. And if you have a website that is using, for example, a single-page JavaScript application, you have a very good way of interacting with the users. And at the end, this JavaScript application, once the code is downloaded, is just behaving like a mobile application. It's just doing API calls. So now we simplified our application. We just need to build an application that is capable of answering in a good way to the API calls that all the consumers, the websites, the mobile application, the wearable, the Internet of Things are doing. And maybe we can also start to expose this API publicly, so that we have external consumers, other services that start to interact with our application. And this is very important. Maybe a lot of you know the story of Instagram. When they launched their application and they became very popular, they didn't have a public API. And what happened is that people reverse engineered and found the way they were interacting within their application, their backend, and start using this non-public API, creating a lot of issues in their backend. So they quickly created an official public API and made it public. So expecting consumers that consume your application as a service is probably something that is very common. And your application will probably have to manage these three things. Starting from the bottom, you will have your own logic, your own business logic, that of course it's your own. But if you consume APIs, you want to make the use of your backend more efficient via caching and throttling. So you want to cache the API results that you can cache, and it doesn't make sense to recompute every time, even with a short time to live. If you can cache an API call for 1 second and you have 1,000 connections per second, of course, this is 1,000th of the use of the CPU and the resource that you have in your backend that you can save. And throttling, if you have a peak because there's a single user that is consuming a lot of your API, you don't want to slow down all your users. Maybe you want to slow down only the abuser of your API. So throttling is an important functionality for API. And of course, you may need authentication and authorization because you may have public APIs, but probably a lot of your APIs need some sort of authentication. And then depending on the role of the user, this user is authorized to use this API call in this way or not. What we try to build with our services is a portfolio of services working together to help you build this application in an easier way. So starting from the bottom, we have AWS Lambda that can run your business logic with, I would say, very high utilization because there is no concept of utilization with Lambda. What happens is that you pay for the hundreds of milliseconds of execution of your code. And if your code is not executed, there's no cost at all because we manage the infrastructure for you. So there is no concept of utilization because you pay only when you really have someone calling the function that you put on Lambda. The API gateway that can handle the interface of your APIs with the rest of the world, it's designed for REST API, so it's very standard, and can handle the caching and throttling. And Amazon Cognito is the service that you can use to manage the authentication and authorization of your users in quite a broad landscape. So let's go a little bit deeper than this. So let's start with Cognito. How many of you did use Amazon Cognito in maybe recently? Okay, we have very few users, so it's a new topic. So Cognito can do this. So you have your end users, the users that will use your application. They can authenticate with an external authentication provider. It can be a social authentication like Facebook, Twitter, Amazon, Google, or any OpenID Connect provider like Salesforce. So you can also authenticate with Salesforce. So your application will delegate the authentication, and all these providers will give you back a token. Maybe they call it token, they call it differently, but it would be a long string that proves that you authenticated with them. What you can do now is that your mobile application, your JavaScript application, or the external service can go to Amazon Cognito, it's one of our APIs, and present itself with the token that it just received. Cognito can check the token with the provider. You have to configure Cognito with the Facebook application or these kind of things. And if the token is correct, Cognito will trust the external authentication and give back a unique identity ID for the user that will follow the user across all the different devices. So if the same user is using the same Facebook authentication on an iPhone in the morning, on an Android tablet in the evening, and in the office via JavaScript application, you always will give him the same unique ID so you can recognize the same user. And it will also give some AWS temporary credentials, so a way to interact directly from your application, your mobile application, your JavaScript application with the AWS services, depending on the role that you specify. So now your application can straight on go on the backend of AWS and use Amazon S3, that is a storage service, for example, to upload a picture without any server in between. There are no EC2 instances here. You don't have to manage availability. You don't have to manage the growth pattern of your users. You just give the ability of the users to upload a picture on Amazon S3. You pay for the storage, and we manage everything else. And this happens with an integration of Cognito with our identity and access management service so that you can really set up a fine-grained policies. So you don't have to care. I'm not going into details here, but you are giving a private space on Amazon S3 so that the user cannot read or mess up with the data of other users. And the same with DynamoDB. You don't need to install a database. You can just use DynamoDB and scale with DynamoDB without having to manage and install and grow and do the tuning of your database. The users can read and write directly on the DB from the application. And the same for mobile analytics to trace the behavior of your users. And Amazon Cognito Sync Store, that is a part of Cognito that extends the functionality that we just saw to provide a key value store that is in the mobile or JavaScript application. And this key value store can be synchronized across all the devices that the same user is using. So for example, if we go back to the example that I give, the user is using an iPhone in the morning with your application, and it specifies that his preferred language is Polish, and that he wants to use meters and not miles in the distance of your application. This can be stored into the key value store of Cognito, and it is automatically synchronized across all the devices that the same user with the same identity D is using. So if he connects later on via JavaScript or with an Android tablet, he will find the right language, he will find the right unit of measure, because this information is synchronized and your application will find it automatically when it starts. And I mentioned external authentication providers like Facebook, Twitter, but we support also external custom authentication services. So if you have your own authentication, you just need to add one API call to integrate your authentication with Cognito. So what happens is the user will authenticate with your authentication service. Your authentication service in the backend, before saying OK to the login, will ask a token to Cognito. So Cognito will give them back a token. And you just give back this token to the users. They can go back presenting the token to Cognito, and of course Cognito will recognize that it's the same token that it just gave and will recognize that the authentication is working. And everything else is exactly like before. So social authentication or your own custom authentication. Okay, now we authenticated your users. We gave them access straight on to AWS services. What can we do more? We can also expose your own business logic via the Amazon API gateway, via REST APIs. So what happens is that your user will ask for from the mobile application, from JavaScript, will do an API call, get this information, give me this image. What happens is they, through internet, will be intercepted by our content delivery network, CloudFront, that is integrated with the API gateway. We have 53 or maybe even more edge locations across the world distributed, and they will go to the closest one. From the edge location, they will enter into the network that we manage, so it will be much better than normal internet. We reach the API geteway, and the API gateway will check, using the credential from Cognito, if the user can call this API. Maybe it's a public API, so there are no credentials. Maybe it's a restricted API, so we'll check the authentication. If the user can use this API call, it will check if it's cached. So the result is already here in my cache. I don't need to ask to the backend to recompute everything. I can just serve the cache that will have a TTL, a time to live. So you can specify 1 second, 1 month, whatever makes sense for the logic of your application. And if the business logic must be called because I don't have a cached value, can do one of three things. Either we call a Lambda function that now will explain better what it is, or we'll do an HTTPS request to a backend that is reachable via internet. So it can be an EC2 instance, can be something that you manage with AWS Elastic Beanstalk, that is our service that makes it easier to deploy an application, start just managing the source code, or can be any publicly reachable internet HTTP server. It can be on premises, it can be on another cloud. But still, the gateway will be in the middle and manage the authentication, the caching, and after the call, we'll also write all the information on the usage of your API in our monitoring service, that is Amazon CloudWatch. So you will have your logs centralized on Amazon CloudWatch, and also the monitoring of the API call, so how many calls an API key of a developer did, what was the latency of the API calls. The latency is increasing, so maybe something is not going well with my API, I should monitor that. And everything is centralized here in CloudWatch. This is an example of how you configure the gateway. I think we will have time to see it live. But the idea is that you have a client and you have a backend resource like a Lambda function or an HTTPS endpoint. And on the top, you manage the request that from the client goes to the backend, the API request. And in the bottom, you manage the response. And then you have on the left, you can customize the interface towards the client. So you can get parameters from the HTTP headers and move them as get parameters, take a parameter and move it to Lambda. You can manage pretty everything that is in the HTTP protocol. And on the right, you integrate the request with the target, like what I want to pass to my Lambda function, what I want to pass to my backend application. To do this kind of customization, we use velocity templates. So there is a standard way of managing this kind of information. So it's not a proprietary platform. You can use any standard velocity template. So you get cache, you get reduced latency, and we also generate automatically an SDK for you. So when you configure your API via the API gateway, there is a button and you can download an SDK for your APIs automatically generated for iOS, for Android, and for JavaScript. I mentioned throttling, so you can say if someone is abusing my API, I want to slow them down. But what happens is that in that case, we answer with an HTTP 429. It's a specific code in the HTTP specification for throttling. And this is intercepted by our SDK. So if you use the SDK that you generate, we will automatically implement an exponential bake-off retry policy. So what happens is, OK, the API now, there's too many people using it. And then we will try after 1 second. If it still there's too much people, we will try after 2 seconds, then 4 seconds, 8 seconds, so an exponential bake-off that will help stabilize your platform. We also support Swagger, so if you design your API with Swagger, you can just import the configuration. And you can implement with velocity templates data transformation in the request and the response. And also you can implement API mocking. So if you want to mock your APIs for testing, you can do that with the API gateway. An important feature is also that since all the traffic goes through our CDN, to our content delivery network CloudFront, you also get protection from distributed attacks because you're not a single endpoint. You have 53 endpoints across the world where the user must put their load and that we monitor. So you get DDoS protection with the use of the API gateway. Last point is AWS Lambda. So for now, we authenticated the users. We can filter how they work with the API gateway. I will give a more clear example afterwards, but still we have to put your business logic somewhere. Usually you have to install something, you have to create a container, you have to build something for your business logic. With Lambda, you just put your functions on AWS, and we will execute the function for you. You pay only for the hundreds of milliseconds of execution time. And every month, to all the accounts, we give for free 400,000 seconds of execution time with 1 gigabyte of memory. If you use less memory for your function, you have more seconds. So the minimum amount of memory that you can put to give to a function is 128 megabytes. And you have 3.2 million of seconds of free execution time on Lambda every month. So Lambda, OK, let's see the flow, and then we will discuss the languages. So you can have this API call that goes through the API gateway. And this API call will be forwarded to Lambda with the configuration that we mentioned before. Or you can directly, using our SDK, invoke Lambda, but you will miss all the caching and the throttling and the security of the API gateway. Or you can have integration with external services like our Amazon Alexa Skills Kit and voice service. It's a new service that you can use with the physical device, the Amazon Echo, or you can use them via API and integrate it in your application. We basically do voice-to-text conversion. We give that so the user can speak with your application. We translate it into text and then call a Lambda function with the text. You elaborate a result. Maybe the user is asking for a restaurant or for a specific service. You give back the text, and we will read back the text, transforming the text to speech, so to voice again. So it's an interesting SDK that's integrated with Lambda. But Lambda can also be triggered by events inside AWS. So any resource on AWS, of course, can have events. Something can change. And we are adding more and more of this resource as a source for Lambda that can trigger an event. So if someone is loading, for example, a picture on S3 or changing something on the storage, this can trigger an event that goes to a Lambda function. If someone is changing something on DynamoDB on the database, you receive the old and the new version of the data, and you can use your business logic to understand what is happening on the database and take your own decision. Amazon Kinesis is our streaming service that you can use to stream information. For example, if you have an application that sends data from your device or from sensors in an Internet of Things network to a central processor for managing the events and processing the events, you can use Kinesis to stream this information, and Lambda function can be automatically triggered to consume this information and process it. I mentioned at the beginning the Cognito Sync Store, so the capacity to synchronize this information across device that is embedded in Cognito. You also get all these events in a stream that you can process with Lambda function and change. So you can know and understand what your users are using. So if you see maybe that users are changing their language, you can understand that and put this information maybe in a dashboard so that you can see how many languages your users are using in the preference of your application. And also, you can trigger this with SNS. SNS, Simple Notification Service. Amazon SNS is our notification service. It's embedded in AWS, so you can use it for a lot of functionalities. For example, CloudWatch alarms. So if there is an alarm, it can trigger an SNS. It's actually an SNS notification. Auto-scaling, if your infrastructure is growing or shrinking, it can send SNS notification. So a Lambda function can consume this. So if you want to play with this, I have a couple of Lambda functions in my GitHub account that can take a notification from SNS and forward to if this then that, if TTT. It's a web service, website that you can use where you can configure a workflow of activities. If TTT, it's nice because it's integrated with a lot of other services and devices. For example, I have the Philips Hue, the smart lights from Philips that can change color and can be turned on or off via API. So what happens is, if I have a CloudWatch alarms, my Lambda function is taking the alarm and can forward that to my lamp that turns from white to red. Or if my infrastructure is growing, so my auto-scaling group is telling me that it's growing, I can intercept that and my light turns green. If it's shrinking, so maybe I'm losing users, it can turn yellow, so maybe it's better if I check if something is going wrong. Of course, this is just an example, but if you want to play, everything is in my GitHub account. This is just to give a little bit more, to go a little bit more concrete on Lambda. Lambda can support, as per today, JavaScript and Java 8. And all the languages that run on a JVM, like Scala or Clojure. And every Lambda function is actually a function written in the specific language, a method in case of an object-oriented language like Java. And it takes two information: the event, that can be something you pass through the gateway, or something that happens because S3 is triggering an event, you change something on a file, and the context around that event. And you can use this information inside your file, and then you can terminate your Lambda function with a context succeed or context fail, passing a result, and that ends your Lambda function. The hundreds of milliseconds between the invocation of the function and the first time you call context succeed or context fail will be what you pay for using the Lambda function. We will manage the availability, the scalability of the function. So if the function is executed 1 every second or 1,000 every second, you don't have to manage the scalability. We will do that for you, where you just pay for the execution time. So you get a backend that scales and performs very easily to a very high throughput. And one important idea here is that you can build your backend to be event-driven. For example, something happens, so a user uploads a picture, and then something reacts and happens in your backend. If you think of your development in the front end of a mobile and web application, it's already event-driven. You push a button, you write something, and something happens. The backend, traditionally, they are not event-driven, and this makes them very complex to write, to scale, to manage. If the backend is event-driven, The scalability, for example, comes out automatically, because if a user is doing something, then you have an event, and this event can be 1 per second or 1,000 per second, and everything is managed by the infrastructure. You don't have to think about the scalability. So let's see why I push on the fact that API Gateway and Lambda together can be a good fit. Let's see how it works technically. So with the API Gateway, you have a resource that is the URL that you call. And since these are REST API, you have different behaviors depending on the HTTP verb. I'm going a little bit technical. Let me know if you need more information. The HTTP verb that you use to interact with this resource. So if, for example, you have a resource /books, so you want to build one of the basic example of REST APIs is the bookstore. So you have /books. If you do an HTTP GET, that is the normal behavior of the browser, what happens, you can map this to a Lambda function, that is get all books. So give me the list of the books. I do get on /books. If I do post on /books, the REST API tells us that you are creating a new resource. So I call another Lambda function that I can call, for example, create a new book. I'm creating a new book. And if you go for a specific book, so you call /books/ and you have something that is the ID of the book, maybe the ISBN or something like that, then you can do a get, a put, or a delete. And the get will get the book by ID, the specific book. The put will create or update the book by ID. Create or update, because put in a REST API is idempotent. So if you call it twice, the result must always be the same. So if you call it twice, you either create or update the book. And the same for delete. It's idempotent, so if you call it, it will delete the book by ID, and the second time the book will be no more there, but nothing changes. So this is an idea how you map an HTTP resource, the HTTP verbs with the API gateway to Lambda functions, and you can create a REST API very, very easily. So let's put everything together and build a media sharing application without a server using the API gateway and an event-driven approach. This is my mobile phone, and I will use three types of arrows here. The blue one are invocations, so it means that I'm invoking a service. The green one means that I'm reading from a specific information source, and the red one means that I'm writing or sending information to another information source. So this is a media sharing application like Instagram. So I want users to upload pictures, share them with their friends, maybe understand if they work close to a place where someone else uploaded a picture so that they get a mobile push notification. What happens is that at first you authenticate your user with Cognito. So maybe they use Facebook or they use Twitter, and then you use this token to authenticate them with Cognito. So now you have a specific ID, and every device they use, you can recognize that it's the same users. Now, with the credential that they get, they can straight upload their picture to Amazon S3 without any server to manage, without any code to write. It's just a call to upload the picture to S3, and we store it, replicate the image into multiple data centers with all the features of Amazon S3 that I'm not describing now. But this is an event on AWS, so I can intercept the fact that something has changed on S3. A function with this event, so the type of object where this object has been uploaded, will be given to a Lambda function that will start and can, for example, extract the metadata, because S3, when you upload something in S3, you can add metadata, or can just take the basic information, like the size of the picture, the resolution of the picture, and write this information in a bucket usage table on DynamoDB. So now I know what the user are uploading and what is the size, the resolution, and I can maybe trigger another Lambda function with this new information that I have on the database and check if the resolution and the size is okay. Maybe the user is uploading pictures that are too big for my application. And if it's too big, the Lambda function can delete the picture and send a message to Amazon SNS that will send a mobile push notification back to the device saying to the user, sorry, your pictures have been deleted because it's too big, it's outside of our policy, or it's an image format that we don't support. But you can attach more than a Lambda function. So the media bucket, when you upload the picture, you have another Lambda function that will extract the metadata. For example, you put information like the author of the picture, the GPS location of the picture where the picture was taken, And you extract all this information and you write this information on a media metadata table where you have all a row for every picture with all the relevant information of the picture. And this can trigger another Lambda function that will group the information per users, and you can create a user stat table where you have for every user how many pictures he uploaded, maybe the most important location that the user is using, all the relevant information that you want to extract to understand what a user is doing. Then we can start to use the Amazon API gateway. So we start to have REST APIs. And one REST API that I want is to describe a picture, to get all the relevant information from a picture without having the content of the picture. So I can have a Lambda function that will be a get information from the media metadata table. So it will tell me this is the title of the, for example, with a picture ID, I get the title of the picture, the location of the picture, the user that uploaded this picture. And I can also use Amazon Kinesis, the streaming service, to send information. In this case, maybe if the user is OK, every 5 minutes you can send the GPS location of the user. Where is he now? And this will trigger a Lambda function that will write the location of the user in another table. It will be a user location table. So I will have in this table, for every user ID, the latest position of the user that was sent from the device. And this can trigger another Lambda function that will read will search in this table for the users that are close to him, or can search for pictures that have a GPS location that is close to the user. And if there is something relevant, like there is a picture that was shot yesterday close to you, or there is one of your friends that is just less than 1 kilometer from you, you can use this information to send the information back via Amazon SNS. Sorry, it was before here. And then you can use the API gateway to create other APIs, like to get information on the user and not on the media. You can also intercept all the changes in the local key value store. So if the user is maybe using the local key value store to rate pictures, you can use this information with Lambda function and put your logic on top of that. Or just store all the changes of the user. So if you see how many users change the language from English to Polish or from Polish to English, if I see that a lot of users are going back from Polish to English, maybe my Polish translation is not very good, so I must improve it. And the idea is that you can build this whole application without a single operating system to install, to patch, to manage, without caring of scalability, because everything is managed by Lambda. And everything, at the end of the presentation, I would probably be completely wrapped by the cable. And so it's very easy, and you just need to focus on what is important for you. And another benefit is, at the end, all this application is a list of small functions. So a lot of small functions that if you look at them, it's a microservice architecture. So without having this in our mind, we built the application with a microservice approach. A lot of small functions. I can also use different languages. Maybe I use JavaScript, where I think JavaScript is a good fit for a function, Java or Scala or Clojure, where I think it's a better fit. And I get a microservice architecture for free. So you can really focus on your idea and not in managing platform, managing complexity. And all the services that I mentioned, they are available with a free tier. So for Lambda, for all the accounts, you have this 400,000 seconds every month of execution time for free. For Cognito and the Amazon, for Cognito you have 10 gigabytes of storage for key value stores and 1 million synchronization per month. And for the API gateway you have 1 million of invocation per month. The only thing is the API gateway, it's only for the first 12 months of your account. So if you have an account, now we launch the service, so for the first 12 months you get the free tier. After 12 months it will expire. But for Lambda and Cognito it's always like that. So you can start, and probably a startup can build a new service without having any cost until you have in the order of the 10,000s of users, so starting to be successful. And to play a little bit more with the technology, I try to bring here something more. So we are glad to give you $25 of credits that you can get following this link, or if you are lazy like me, just taking a picture of the QR code. But we will also send this link by email, so if you don't catch it now, don't worry. and I will show it also in the next presentation. So with $25 on top of the free tier, you can really do a lot of things, and let us know what you build. So the idea now, I have still 5 minutes. I want to very quickly do a live demo of what I said, so that I think it will be much understandable. Oh. So the idea is that I want to build a very basic REST API. This is probably something that you already saw. A function that gives you back the IP address you are using. So sometimes you need to know your public IP address. You want to call this REST function, and it will give you back your public IP, the one that on the internet you are using. Of course, it's a basic example. So first I need to build a Lambda function. So I go on this is the Lambda console. And here I create a new Lambda function. This is the way to create a function without managing servers. We have a lot of recipes that you can use for managing the stream of data from DynamoDB. So if, as I mentioned in the previous architecture, if someone is changing something on DynamoDB, you get the feedback here. Or you can want to have an image processing service when someone is uploading a picture on S3. These are templates that you can use, but in this case, I skip and want to start from scratch. I have to give a name to the function. Let's call it what is my IP. And this function will give back your IP. I can choose the language. Recently, I was a heavy user of Java. I like Scala, Clojure less. But recently, I like to play with JavaScript. Maybe I feel younger if I play with JavaScript. And here, I can inline write straight on the code of my function. So in this case, this is the function that I want to use. If I receive an event and a context, this is a very stupid function. I will return with context succeed a JSON payload that will give back a source IP, and is expecting this source IP to be part of the event that is receiving. So in the event, I get a source IP, I extract it and give it back as a source IP. So it's almost returning what it's getting. Here I have to specify which is the handler to export. So you see here I have an export handler, and then in the bottom I have to say that I want to export that, because I can have like 12 functions in my code, and I want to export only one function as the Lambda function. The rest is internal function that I use. Then I have to give a role, because this function can do different things with the AWS resources, like it can read from S3, write on DynamoDB, and to do that, on AWS we have a very strict security approach. You have to give a role that specifies what this Lambda function can do. In this case, I just need the basic execution role. It means that the only right that I give is to write logs on, and information on CloudWatch for logging. I don't need to interact with other services. And this is affecting the cost, how much memory I want to give. As I told you, if I choose here 1 GB of memory, I have 400,000 seconds for free every month. If I use less memory, I have linearly more seconds. So in this case, the function is really basic. So 128 megabytes is probably more than enough. So I will have 3.2 million of execution time for free. And then I have to set up a timeout to avoid a function that goes on running for days, and you continue to pay for these hundreds of milliseconds of execution time. 3 seconds, it's probably enough for the extracting the value and giving it back, so I will leave 3 seconds here. Now I have a recap, and I can create the function. And now the function is live. I can check it, edit. And if this function was using information from other AWS services, like S3 was the source of my events, I use the event source panel to add event sources here, like connect this function to S3, to SNS, to Kinesis, to Cognito, and this will trigger automatically the function. But I want to expose this function via the API gateway as a REST API, so I don't need to do anything like this. Here I have the monitoring, and I can see all the invocation of the function. There is also a very quick integration with the API gateway here. So if I click here, I can do everything with a couple of clicks, but it's too simple. I want to show you the Amazon API gateway console. I will not use this way. So let's go back. Let's go to the API gateway console. So now I am on the Amazon API gateway. I want to build my new API. So I create an API. I give a name like my utils, because maybe I create an API with get my IP and other utility function that I use. I do not want to clone this API, it's a new one. I can, now this is the URL, and here I can create resources that are the part of the path that I use. For example, my IP will be the URL. I can create like /books in the example that I gave before, or /book with an ID. I just create a static resource. Now I have to connect this resource with a method, so an HTTP verb, get, put, post. I will use get. So if I run HTTP get on /my IP, now I have to decide what I want to do. I can connect a Lambda function. I can use an HTTP proxy with a backend function that is already running, do a mock integration for test. I will use a Lambda function since we just built it. I built it in this region, so if I look for it, I find what is my IP. So now I'm connecting this Lambda function, and I'm authorizing the API gateway to call this Lambda function. And I start building everything. But my Lambda function was expecting the IP address in the event. And this is not something that I will give automatically. So I have to change something. And what I can do is go in the integration mapping of this part, the information, the input mapping. So if I go here, I can add a mapping template that will tell that for I'm using JSON. It's quite a standard for this kind of API. And I don't want a pass-through. I want to extract some information from the context of the gateway, and this will extract from the context of the gateway the IP address of the users and put it into the event, so that the event will bring the source IP and I can give it back. Now I will deploy my API in production. I create a version 1 of my API. And this is the URL. Of course, the URL that we automatically generate is not very nice. You can customize with your own domain. You just need an SSL certificate. And now if I go here and do a URL on this API /my IP, this is the JSON return code with my IP address. And if I want, I will not do that because I'm already over time. You can change the syntax. I don't want JSON, I want XML, I want just the IP address. It's all mapping that I can do using velocity templates in the configuration of the gateway. So thank you for staying with me with all the demo, and thanks. Let's give some space to the other speakers.